There we go. Okay, so top of page 4, we did a little bit of work on this. We said that it wants us to solve the triangle, and that means every angle and every side. Now, they're going to have to give you a little bit of information, so here's what they gave you. So we did standard labeling, right? A, B, C, okay? We know side B, and we know angle A, and then we said because of the law of triangles, that all your angles have to add up to be 180, we could very easily find angle B, right? We could very easily do that. So that's kind of where we left off. We still have 2 sides left that we have to get. Now, with right triangles, you always have Pythagorean theorem available to you, but you have to know 2 of the 3 sides. So we can't do that quite yet. That means we're going to have to use SOHCAHTOA, right? So if I'm just going to use the angle they gave me. If you want to use 60, you can. I would recommend using what they gave you. So if I use 30, which means I'm sitting up here in this little corner, this is where I am. I have my adjacent. I need the opposite, and I need the hypotenuse. Okay, well, let's focus on the opposite first. So if I have adjacent and I need opposite, what function deals with opposite and adjacent? Okay, just so happens I have this little handy dandy space over here. Remember, tan theta is opposite over adjacent, right? That's based on SOHCAHTOA, that's the end, the TOA, T, tangent, opposite, adjacent. So that means if I take the tangent of angle A, which is 30 degrees, that's going to equal side A, because that's my opposite, over side B, because that's my adjacent. Is everybody okay with that? And then all we're going to do is solve for side A. Okay, so if I most of you know you're just going to multiply these 2 together, but if you need to see that algebraically, you want to get rid of the denominator. You have an equal sign. So if you multiply both sides by the denominator, what you get is 7 times tangent of 30 degrees. Okay, so remember, we want to make sure that we're in degree mode, okay? And then I'm going to do 7 times tangent of 30. And I get 4.04. I'm just going to round it, okay? So my A is 4.04. There we go. Okay, the only thing left that I have to find is my hypotenuse. Now you can go back to your 30 and you can use adjacent over hypotenuse and solve for that, or because it is a right triangle and I have both legs, I could do Pythagorean, right? So I could say that 4.04 squared plus 7 squared equals c squared. If I put those in my calculator, I get 65.3216 is c squared. Take the square root of both sides. Turns out my c is 8.08. And that's my answer. And I have solved the triangle completely. Okay? Does that make sense for everybody? All right, so again, you just use what they give you. Make sure you're sitting in that little angle area, right? So that you know what opposite is and you know what adjacent is and all that good stuff. Okay, we ready for example 8 then? It's the same thing, we're just gonna practice some more. Okay, you scoot it up a little bit here. Okay, so we want to solve the triangle. That means we need all the sides and all the angles. So let's go ahead and label them. This is definitely my right angle, by the way, right? Okay, so I start up here. This is A, B, C, okay? And then I put in their lowercase letters across from them. That's your standard labeling. I just went around counterclockwise with A, B, C, okay? All right, then the information that they're giving me is off to the side. So this time I know my hypotenuse, it's 9. And I know angle B, which is 30 degrees. Okay. Now it also happens, I know angle C, right? Because that's my right triangle. So he's also 90. Okay. Well, I got to find everybody else. I always like to go ahead and get the angles out of the way if I can. So I know 2 angles. How am I going to find my third angle? Perfect. Okay, so law of triangles says all 3 angles add up to be 180 always. So I can either do 180 minus 90 minus 30. That's going to give me 60. That is going to be what angle A is. Or Elizabeth said, we know 180 minus 90 is 90. So these other 2 have to add together to be 90. So 90 minus 30 is 60. Either way, you come up with 60. Okay, so we know angle A. We solved all the angles. All right, now we need the 2 sides. I can't use Pythagorean yet because I need 2 sides and I only have 1. Okay, so again, you can choose to sit up here in 60 or you can choose to sit down here in 30. I, again, would stress to you, I would sit where they give you, what they give you. So if I'm sitting down here in 30 degrees, this is where I am. I need opposite and I need adjacent, but I'm given hypotenuse, okay? So if we remember SOHCAHTOA, right? We know our sine is gonna be opposite over adjacent, and we know our cosine, no, that's not right, good gracious. Okay, hypotenuse. And our cosine is adjacent over hypotenuse, okay? So those are the little tools we have at our disposal, only because we have a right triangle. That's it. Okay. What you're going to find is once we leave 8-1, you no longer have right triangles. So you cannot use Pythagorean and you cannot use SOHCAHTOA, right? Okay, but for now we can. So if I'm sitting here on 30, I don't know, let's find, what do you want to find first? Cosine or sine? You want to find A or B? I don't know what that was. A, okay, we're gonna find A. Oh, capital, okay, I got you. I was like, okay. So let's find A first. If I'm sitting here and I wanna find adjacent and I have hypotenuse, then I'm gonna use the cosine. So I'm gonna have cosine of 30 degrees equals adjacent over hypotenuse. Okay, perfect. Is everybody okay with that? Okay, so again, you can just multiply cosine 30 degrees and 9 together, but if you need to see how that works, right, then you can multiply both sides by 9. Okay, let's do it in our calculator together so that we're comfortable with it. Okay, sorry, I have to move it over here to put it in the light. Okay, so I'm going to have 9 times cosine of 30 degrees. Okay. And that gives me 7.79. Whoops. Okay. That's my A. All right. You have 2 choices. If you like doing it this way, you could go right over here and do sine of 30 degrees is opposite over hypotenuse. Multiply it by 9 and get B. Or you can do Pythagorean. 7.79 squared plus B squared equals 9 squared. You can solve for B that way. You have a lot of different choices here with right triangles. Okay, so it's up to you whichever way you want to do this, whatever you like better. I'm just going to multiply both sides by 9, just like I did here. Okay, that's going to give me 9 times sine of 30, and I get 4.5. Now, if it wants 2 decimal places, make sure you put a 0, 4.50. You know how finicky my math lab is, okay? If you wanted to do it like this, okay, then you're gonna have to kind of rearrange it a little bit and solve for B, but you're gonna get the same answer. So it's your choice, you know, what you wanna do there. Does that make sense? Okay, so far, law of triangles, Pythagorean, and SOHCAHTOA. You can get through anything with those, with the right triangle. Okay. All right, let's do last one. Okay, this one's just a little different. and then we're going to get into some word problems. Okay, so again, our directions are going to say solve the triangle. All right, so standard labeling gives me ABC going counterclockwise, where that way C is always your hypotenuse, so you kind of get used to doing it that way. Your little sides across from each other. Okay, this time they give us two sides and they don't give us any angles. So this is going to be 4 and this is going to be 7. Okay, all right, well, what are we going to do first then? Say that again.
Assume they're 45.
No.
Oh.
What is that? Okay, do not listen to Ish.
Why? But it makes sense.
Because they're not 45. Okay. All right, that took a dark turn. Okay, anyway, where I was going is if you have two sides, how do you find your third side? There, Pythagorean. Okay. Oh my goodness. Make me get up and come over there, Ish. Yeah, I'm not doing that. All right. Okay, so I'm going to have 4 squared plus b squared equals 7 squared. I'm not on the right page. That would help. Okay, that means b squared is going to be 33. We're going to take the square root of each side, and b is 5.74. Notice I didn't really talk about the directions up here, but normally in my math lab and in trig anywhere, your sides are 2 decimal places. Your angles are 1 if you need them. Now 30 degrees, you don't need one. 60 degrees, you don't need one, but that's normally, and it tells you that up there if you need it. Okay, so we have all our sides now, and all we have is the one little angle there. Okay, well, here we go. We don't want to use 90 degrees. Whenever you're dealing with SOHCAHTOA, you really want to avoid using the 90 degrees because think about what's going on at 90 degrees. At 90 degrees, your cosine is 0 and your sine is 1. So you want to kind of avoid that because it doesn't always come out to give you everything you need, which means we're going to have to just kind of think about what it would take to get what we need. So let's just pick an angle. What do we want to solve for first? Angle A or angle B? Ish, you're going to have to sit outside and look through the window. Okay. All right. So angle A or B? Who picked one? A. We're going to solve for angle A. Okay. So we're up here at angle A. This is where we're going to sit first and solve for him. Okay. So I was given the A and I was given C. So I was given opposite and I was given hypotenuse. So let's use those values just in case I made a mistake on B. So what is opposite hypotenuse? Sine, right? Opposite hypotenuse. Y'all are all going to look through the window. Okay. Opposite over hypotenuse. So if I take sine of theta, because I don't know what this angle is, opposite over hypotenuse, okay? How do I find theta? How do I put that in my calculator? If I know the sides, but I don't know the angle. Yes, you're allowed back in. Okay, Daisy's back in the room. Okay, so we're gonna do inverse. If you don't know the angle, don't know theta, then you're going to use inverse. That's what we're gonna do in our calculator. If you don't know theta, use the inverse. So in my calculator, I'm gonna put inverse sine 4 divided by 7, and that's gonna give me theta, okay? All right, so here I go. Still in degree mode, because that's what I want. I'm gonna do inverse sine 4 divided by 7, and that's gonna give me 34.8. That's all I did. Inverse sine 4 divided by 7, and I get 34.8. And that's degrees. Okay, that's what's going to go up here in this little area. That's my A. All right, now you have 2 choices. So you can find angle B using adjacent over hypotenuse, right? Inverse cosine. Or now you know 2 angles and you want the third, you can do 180 minus 90 minus 34.8 and find angle B. So let's just talk about your two choices. You can do 180 minus 90 minus 34.8. That's going to give you angle B. Or if you like to use SOHCAHTOA, if I'm sitting right here and I want angle B, I was given adjacent and hypotenuse. That's going to be cosine of that is going to be 4/7. Okay, so you would have to do inverse cosine 4/7 to find theta. Okay, so either one of those would work, and you're going to find that B is 55.2 degrees. Okay. Yeah, and also 90. Absolutely, absolutely. Yep. Okay. Yeah, the only reason I keep going back to the 180 minus minus is because when we leave this section, we're still going to need that, and you won't be able to do the 90 anymore because you won't have right angles. So that's why I keep saying it. But yeah, for this, that's perfectly fine.
Why did you say we're not doing 90s?
Huh?
You said we're not doing 90s. You want to stray away from 90s, so.
No. I just meant using him as a yes.
Oh, okay.
Yeah.
So,
Yeah.
Okay.
Yeah. Sorry. Okay. All right. Does that sound okay? You can either use the 180 minus minus, or you can use the inverse cosine. Either way, you'll get everything done. Okay. So that's really the whole section. Now they just like to give you a lot of really crazy word problems. Okay. So we're going to do all of them. All right. So up to this point, we have covered up through my math lab number 10. They've all just been, you know, every single problem we've done. Example 7 was my math lab 8. Example 8 was my math lab 9. Example 9 is my math lab 10, and so on. Okay, so now we're going to go down here to number 11. We're going to start some word problems. There's not a picture for this guy, but the rest of them have pictures. Well, no, one of them doesn't. Okay. All right, here we go. So we have, I think this is one that's on your test. We don't do a lot of word problems on a test, but I think this one is. So we just want to make sure we can do this one. Okay, so we have a building. Okay, just make a little building. Here's your building. Here's your little door. There's your building. Okay, got a building. He is 400 feet tall. Okay. He's going to cast a shadow 50 feet long. All right. What is the elevation of the sun? Okay, y'all all just looked at me like I said, what color underwear am I wearing? Okay. No. Okay, it's just throwing it out there. All right. First of all, if this is 400, okay, and this is a building, let's pretend that the construction crew was like super smart and it's straight, okay? And that's a nice little 90-degree angle with the ground, okay? This is not the Leaning Tower of Pisa. It's a really well-built building, okay? All right. Let's also think about, where is a shadow located? Where have you seen a shadow located? If you're walking around outside, where's the shadow? I'll take it. It's on the ground. It's not floating around here. There goes the shadow. There goes the shadow, right? Shadow's on the ground. Students have a real hard time figuring out where to put the shadow. The shadow's on the ground. Everybody got it? Okay. So here's the shadow of the building, and it's 50 feet long. Everybody okay with that? We're going to make a triangle. We're out here. We're going to make a triangle with the top of the building, because look what we just made, a right triangle. Building's 400 feet tall. We got a 50-foot shadow. All right. Elevation means from a flat point looking up. So what angle are we looking for? Where's our theta? Right here. There's our theta. We're looking up, okay? It's not this. We know that angle, it's 90. This is not an angle of elevation. That's an angle of depression. We're looking down.
Yeah.
Our little elevation is from the ground up. And here's our shadow, okay? On the test, there will be somebody in here who tries to tell me this is 50 because this is where the shadow is. I will call you out. Your name will be on the board. Shadow floating in the air-ish, okay? The shadow's on the ground. Everybody got it? Okay. All right. So now we're good. So you totally know how to solve this, but make sure that you can set this up. Easy enough once you draw it? Okay, building, shadow, looking up at the sun. We're just finding this. All right, here we go. So if this is my angle and that I'm looking for, and I am given opposite and I am given adjacent, who am I going to use? Which part of SOHCAHTOA is opposite and adjacent? Tangent. Okay, that means my tangent theta is going to be opposite over adjacent. There. And remember the trick. If we don't know theta, how are we going to put it in our calculator? The inverse. That's another thing students really struggle with. If you don't know the angle, you have to put it in as inverse. Okay, so we're going to have second tan, 400 minus 50, and then we round 82.9 degrees is our theta. Okay, I'm just kidding. I won't put your name on the board unless you are Ish. It's okay. All right, and maybe Abby, but that's it. Okay. All right. Does that sound okay? All right. All right, so that one was an easy one. These others, not so easy. You don't have them on a test because they're pretty confusing, but we're going to go through them because they're on your homework and they're on your quiz, bless you. So we want to make sure you can do them. What you got, Elizabeth? Nothing? Oh, I thought you had a question. Okay. Oh, yeah. Okay, so here we go. Did I not give you a picture of the state trooper? I'm sorry. I must have forgot to put him on here. We're going to draw him. This is my math lab number 12, by the way, this one we're about to do. This is the picture you're going to have on my math lab. So we're going to draw the triangle in a minute. But basically, I don't know, it's some mountain state. Here's a mountain. There's a little trooper behind the mountain. And he's trying to catch speeders. And he forgot his little speeding gun, right? But he's really good at tricks. So he that's so this, okay. I don't know. Give me a break. All right. So here he is. He is. Yes. Okay. So all right. So this is what it tells us. We'll draw a triangle together, but they're going to give you this on my math lab. So the state trooper is hidden 30 feet from a highway. So the highway is the horizontal, and he's perfectly 30 feet straight back. So there's our right angle. Okay. And here's our distance for this guy. All right. Then 1 second from this point to here, the truck passes. It takes the truck 1 second to go from here to here. Now, the 1 second is important, but that's not that length. That's a portion of time, right? We don't know the length of the triangle right there. We just know that it takes the truck 1 second to travel that length. Okay, boom, he's here. Okay, this is the trooper's angle of observation, this theta. All right, this is what we're going to be looking at. So we're going to draw a little triangle. I'm sorry I didn't copy and paste the thing for you, but here's what you're going to have basically is this. Okay, it's kind of this right triangle upside down. This is 30 feet. Okay, we don't know this side, but we do know that it takes a truck 1 second to travel it. And here's our theta. Okay, that's basically what we're dealing with. Everybody okay with that? All right. So if this angle, so for part A, they're going to keep changing the angle on you. But for part A, your angle is going to be 16 degrees. This wants to know how fast was the truck traveling? And it wants the answer in feet per second and miles per hour. Okay, so I know again, it feels like it gives you things that aren't related at all and asks you how to bake a muffin, right? But you just have to fill in all the little parts and then it comes together. So what I can figure out then is I don't need to be worrying about solving the whole triangle. What I need to know is this distance. Does everybody kind of agree with that? If I knew this distance in feet, I know it takes 1 second to travel that far, I would have the answer in feet per second. Then I could do a little conversion to miles per hour. So I'm trying to find this particular measurement. Okay, well here is the right angle. So we know this is C. You can call either one of these, A or B. I'm just going to call him A, just so I have something to call him. All right, so if I am sitting here, here's my angle, and it's 16 degrees. I have opposite, but I don't have adjacent. So again, who deals with opposite and adjacent? Tangent. So you're probably figuring out that honestly, in real world applications, tangent is what's used a lot over and over and over again. But anyway, so we're going to use tangent. So I know that the tangent of 16 degrees is going to equal opposite over adjacent. Okay, so first question, do I need to use inverse tan in this situation? No, because I have my angle. Remember, inverse is only when you don't have the angle. Now, this part actually is a little more complicated than what we've done before because I can't just multiply two things together. It's a little bit more complicated. So a couple of things you can think about. The quick and dirty way is you're just going to replace these two. Your A is going to be 30 divided by tan 16. The math behind that is the same math we did earlier, where if we multiply both sides by the denominator, we're going to get A times tan of 16 degrees equals 30. Then we solve for A, so we're having to divide both sides by tan of 16. And your A is going to be 30 over tan of 16 degrees. So these little SOHCAHTOA things are super easy when what you're looking for is in the numerator because you're just multiplying the bottom and the other side. When what you're looking for is in the denominator, you have to switch it around a little bit. When what you want is down here, you're going to have to trade places with these two. It's going to be the numerator divided by the other side. Does that make sense? So we kind of went through the algebra. We multiplied both sides by the denominator, and then we divided the tan 16. So this is what we're going to put in our calculator to get our A. Okay, so we're going to do 30. I'm going to turn it on. Okay, 30 divided by tan of 16. And I get 104.62. Okay. So A is 104.62. Okay, that's how the distance that this is. All right, that's not our answer yet. Okay, it wants our answer in feet per second. Well, this is feet. How long does it take to travel that? 1 second. So if I divide 104.62 by 1, what do I get? 104.62. That's my feet per second. If it took 2 seconds to travel that far, I would divide it by 2. If it took 3 seconds, I would divide it by 3. Okay, it just so happens this truck goes that far in 1 second. Okay, now I'm not done. Now I need this in miles per hour. Okay, so we need a couple conversions here. First of all, how many feet are in 1 mile? Okay, 5,280 feet in 1 mile. You're going to need that little conversion. Now I want to go from seconds to hours. How many seconds are in an hour? Anybody know that? That's 3,600. Now you don't have to go straight there. You can go seconds to minutes, minutes to hours, but there's 60 seconds in a minute and 60 minutes in an hour. So if you multiply them both, you get 3,600. Okay. All right. So now let's do a little conversion. Okay, this is your little chemistry training coming into play here, right? So, whoops. Here we go. This is feet per second. All right. First thing we want to do is change the feet to miles. So here we go. This is the conversion we're going to use. We just have to figure out who goes on top and who goes on bottom. We want our feet to cancel. So I need to put who on the bottom? Feet, right? Here's my feet. I want feet to cancel, so I'm going to put this side on the bottom so that feet cancel, and I end up with miles on the top. Okay. Now I'm in miles per second. Now I want to be in miles per hour. So now I go to this conversion. I want my seconds to cancel. So who's going to go on top? The 3,600, the seconds. in the 1 hour on the bottom. Now my units are miles per hour. Okay, so in my calculator, I'm gonna do, okay, where you guys can see it, 104.62 times 1 times 3,600 divided by 1 divided by 5,280 divided by 1, and I get 71.33 miles per hour. That's how fast the truck was going. Okay. All right, how do we feel about that? Yes.
How did you get the, I know you divided 30 over 10 of 16, right?
Uh-huh.
How did you get the 104? Did you do something else or you just divided it?
Say that again. How did I get the what?
The 104.62.
Oh, okay. So this was the 30 divided by this, and it gave me that. You mean, how did I get it over to here? Did you not get that?
No, I got 99.7.
Are you in degrees?
Oh, okay.
Okay, yeah, go in degree mode. Do it one more time. That'll do it. Okay. Anybody else? Good. Let me just verify Elizabeth's calculator is not losing its mind.
Oh.
Got it? Okay, good. All right. Okay, let's look at B. All right, now B is saying, what if the angle's 25 degrees? What if, okay, here's our little trooper picture. This was 16 degrees. What if our angle's a little bigger? What if our trooper moves out here a little more and our angle becomes a little bigger, right? Or he moves back, you know, just so he can see a little more. Then if the truck traveled that far in 1 second, then how fast is he going? So they're changing your theta. Now they're saying, oh, just kidding. Do the whole thing again with 25 degrees. That's what they want you to do. Okay, so let's go back up here. Remember what we did. All right, first of all, we need to get A now that our angle is 25 degrees. Okay, so we're going to do tan of 25 degrees. Opposite is 30. Over adjacent is A. And then we showed how we got the math, right? But remember, if what we want is in the bottom, anybody, we can just real quick and dirty switch places here. So I can say A is 30 over tan of 25. Is everybody okay if I just do that? You guys can kind of see how we did it up here. Is that all right? Okay. All right. So now if I put this into my calculator, I came up with 64.34 feet. And it's going to be per second. I guess I should just put feet, because when I divide it by 1, I get 64.34 feet per second. Okay, truck is going slower. Does that make sense that the truck is going slower? Let's see. If this is now 20, this is shorter, so the truck's going slower. If I want it to come out to 25, and I guess he's not changing his positions, we're having to shorten it a little bit to get there, right? To make this a little bigger. Rather than come this way, we had to shorten it a little. So that kind of makes sense that A is not going to be quite as long if we're going to make that angle bigger. All right, but we want to know how fast is he traveling in miles per hour. So we're going to have to do this conversion again. We're going to have 64.34 feet all over 1 second. Okay, we're going to again put 1 mile in the top because we want our feet to cancel. And again, put seconds in the top because we want our seconds to cancel. And we work through that, we're actually going to get 43.87 miles per hour. And there's our answer. Okay. Now we did that one fast, but I just thought we could probably just look back at the one we just did. Is that okay? All right, last one. So here's what we've done so far. Okay. So far, we have been given an angle. We found a side. We found a side in feet per second. Then we went to miles per hour. Well, guess what we're going to do now? We're going to work back the opposite way. So here we go. Now this tells us, okay, if the speed limit is 80 miles per hour and a speeding ticket is issued for speeds of 10 miles per hour or more over the speed limit, for what angle should the troop issue a ticket? Okay, so now we're going to work the other direction. We're going to take miles per hour and change it to feet per second, multiply it by a second, which gives us feet, and then do inverse tan to get an angle. So we're moving exactly in the opposite direction. So let's figure out what miles per hour to start with. We are talking about issuing a ticket. So do we want to start with 80 miles per hour? Is that when they get the ticket? No. At what speed did they start to get a ticket? 90 miles an hour, right? The speed limit's 80, but the trooper doesn't actually give them tickets until they go 10 miles over that. So 80 plus 10 is 90. So the tickets happen when they're traveling 90 miles per hour. That's when the ticket comes along. Does that make sense? That's why we're starting with 90. Okay, we're going to go from miles per hour backwards to feet per second because we're working back this time. All right, so we're still going to use these conversions, but they're not going to go in the same places that they did because now we want to cancel out to go back the other direction. Okay. All right. So let's see, if I have miles and I want to go to feet, so I want my miles to cancel. So I'm going to put miles on the bottom and I'm going to put feet on the top. Does that make sense? Is that okay? I wanted my miles to cancel, so I put them on the bottom and the feet on the top. Now I want my hours to cancel because I'm trying to go to seconds. So my hours down here, he's got to cancel with somebody up here. So my hours going to go up there and my 3,600 seconds are going to go down there. It's exactly the opposite because we're just going the other direction. Okay. I'm going to do 90 times 5,280 times 1, divided by 1 if you want, divided by 3,600. And you should get 132 feet per second. That's the speed that's going to give them a ticket in feet per second. Is everybody okay with that? Okay, now the trooper's still using the 1 second rule there. So we want to know how long is that distance in 1 second. So we're going to multiply by 1 second and get 132 feet. We're just working backwards. On A and B, we divided by 1 second. On these two, we're multiplying by, on this one, we're multiplying by 1 second. Okay. So my triangle is 132 is A. Okay, so if I were to redraw this, all right, here's my right angle. This is still 30. I've now determined this is 132, and I'm trying to find this theta, this angle. So I'm just working back to find that angle. This is my hypotenuse. So let's think about this. I'm sitting right here and I have opposite and I have adjacent, tan, okay? So tan theta equals opposite over adjacent. Now, how am I gonna find that in my calculator? Inverse. Inverse tan, okay? Inverse tan of 30 divided by 132. And I see that theta comes out to be 12.8 degrees. Okay, so what my math lab is asking you is, for what angles, it's plural, what angles should the trooper issue a ticket? For what angles? Well, what I notice is that at 16 degrees, it's 71 miles per hour. 25 degrees, I'm 43 miles per hour. 12 degrees, I'm 90 miles per hour. So the bigger the angle, the slower the traffic. So do I want 12.8 degrees and bigger to get a ticket, or 12.8 degrees and smaller to get a ticket? Smaller. So you're gonna want 12.8 degrees or less are the angles you're looking for. I know this is a really long, stinky question. They won't let me take it off, but just kind of follow the paper when you get to number 12, and hopefully, you know, you can avoid it on the practice problems and find some that aren't this, okay? Oh my gosh, there are so many pre-calc. We're about to get to the airplane with the bearing and the angle, and then we have the lost ship. Yeah, they're like all pre-calc word problems. They're like all the same, yeah. Okay, Abby used to come home from pre-calc and flip, yeah. We would look through my book and try to match up word problems with what she was doing. Okay, that all right? Kind of stinky, but you can kind of get through it. All right, example 11. This is my math lab number 13, and this is my math lab 14 with the bearing there. Okay. Okay, we don't have a picture for either one of these, so we kind of got to draw them. All right. Oh, hold on, I'm all blurry too. Come on, camera, you can do it. There we go. Okay, so we have a security camera in a bank, and it's mounted on a wall 8 feet above the floor. So 8 feet, we have a camera. Okay, here's our floor. Okay, everybody okay with that? All right, what angle of depression, right? So now the camera's up here, like this is your ceiling basically, is up here. You got a little 8-foot ceiling there, okay? What angle of depression should you angle the camera down if we're trying to get it to look at a place 6 feet above the floor? So in the bank, you don't want to stare down at people's shoes. Where are you wanting to stare at? The teller with the money, right? You want to make sure that your tellers are counting out the right money and not like one for me, one for you, right? And then you also want to know if there's a gun being pulled on the teller or a note slipped to the teller. So we're not trying to go all the way to the floor. We're not making a right triangle all the way to the floor. That's where most students go wrong with this problem. We are going to make a right triangle, but it's not with the floor. It's with the ceiling. Okay, so if we only want our camera to go here, if this is our angle of elevation, or I'm sorry, depression, that's what we're looking for right there. Okay, so let's think about this. This weird shape right here, I don't even know what that is not a triangle. Everybody agree with me? So I can't apply what we know to this. However, if we connect the rest of the wall back here and we assume all of this stuff is nice and straight, where's our triangle? It's up top. Sound good? Okay, well, so far we don't know anything about that. But if the whole wall is 8 and the little teller's desk is 6, what's the length of this triangle going to be? 2. Look at there, we have a piece of information. That's as much information really as we get normally. Okay, now let's think. This says, okay, what angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 14 feet from the wall? Okay, that means this is 14 feet from the wall. Well, if this is 14 feet, this better be 14 feet too, right? Your ceiling better be the same length as your floor. Okay, and I think we're good to go. So really it's the picture that seems to cause the problems. Does this make sense, kind of what we did here? All right, if I'm trying to find theta, what do I have? I have opposite and I have adjacent. Tan. Opposite over adjacent. Okay, how am I going to put that in my calculator to find my theta? inverse. If you don't know the angle, you have to use inverse. So inverse tan of 2/14, and we're gonna find out our camera just needs to be angled down just a little, 8.1 degrees, and that'll do it. Okay, sound good? All right, so that one's not too bad. Okay, this one gets a little nutty. Okay, so here we go. Anytime you see the word aircraft, ship, and especially the word bearing, you're in a whole nother universe, right? This is where it tends to be really stinky because the average student, well, the average person doesn't know how to handle bearing because it's so different than anything that we're used to. The minute you see that, I want you to draw yourself a compass, okay? We're gonna draw a compass. And then we're gonna label our compass, north, south, east, west, okay? And then we're gonna kind of think about overlaying our X and Y axis over our compass here. So remember your little compass directions, your little never eat slimy worms? Remember that from like elementary school? Never eat slimy worms. There, now you have your little direction. We knew that would come in handy one day. Okay. Whenever it says bearing and it gives you a direction or a bearing, whether it's a ship or an airplane or whatever, you're leaving from the origin. The origin here in the middle of your compass is where the directions are coming from, okay? And with a bearing, they always put you in like one of the halves first. So if it tells you it's north something, it means you're up here in one of these two quadrants. If it tells you south something, you're down here in these two quadrants, and then you pick east or west. So we have this DC-9, this big aircraft, leaves an airport from a runway, that means the origin, whose bearing, okay, they're talking about the aircraft now. The aircraft's bearing is north, okay, so we're up here, 40 degrees east, we're over here. So our aircraft is over here in quadrant 1, okay? This 40 degrees they're talking about is this angle here, the 40 degrees off of north, okay? So it's real confusing here, but you go north and then 40 degrees off of that east. That's where the airplane is. Now it says it flies for half a mile. Okay, great. Make that 40 degrees, okay. So that means the length of that little stick right there, that side, because we're gonna make a triangle, is a half. All right, then the pilot gets on the radio and requests permission to turn 90 degrees southeast. There's a UFO, there's a storm. He's saving lives. We're going the other direction, okay? So he's up here and then he wants to go, boom. He wants to go south, but stay east. So he's headed down into quadrant 4 now, okay? He's down here. And this is a right angle because it says he turned 90 degrees. Everybody agree with that? All right, heads toward the southeast. Now we're down here in the southeast quadrant. Permission is granted. Okay, the airplane goes 1 mile in that direction. That's that side. So now you have 2 sides, okay? All right, what bearing should the control tower use to locate the aircraft? So now the control tower, which remember is the origin, is trying to figure out where in the heck are you? Here's your airplane, okay? And remember, they have to tell from where they are. So what they need to do is use this straight line from the origin to find it. And look what we just made. We made a triangle. Oh my goodness. Okay, but now here's the stinky part. Here's the part students get confused about. All right, it says, what is the bearing the control tower should use? Okay, the bearing has to be off of the north-south line. It has to be off of here. So if we're down here in southeast quadrant, what the control tower is trying to find is this little mystery angle, this little theta right here. This is the bearing that they're looking for. So this problem, I really hate when they put these in pre-calc and trig books because there's so much information you have to know that how the heck are you supposed to know that, right? But I mean, you're not a pilot, but that's what they're talking about is this angle here, okay? Is everybody all right with that? All right, so first of all, we have a triangle and we have an angle given that's not even in our triangle, and we want another angle that's not even in our triangle. But we just talked about something in the last class. We said that complementary angles add to be 90. Supplementary angles add to be 180. Look at this. This is supplementary if I've ever seen it. This is 40. This is some mystery angle from a right triangle that we can totally find. And then we'll do 180 minus those two to get the mystery bearing. Sound pretty good? Okay. All right. So this is what we're trying to find. Is what's in this little triangle right here. This is the missing angle. Okay. So I don't know what you want to call it. I already used theta. I guess we could use theta again, but well, we'll use theta and I'll just kind of get rid of this. We'll just call him bearing. He doesn't get a symbol. Okay. All right. So if I'm sitting here, right, in this little corner, first of all, where's my hypotenuse? It's over here, right? It's across from this side. So I don't have to worry about him. I don't know what he is. I don't have to know what he is. I'm sitting here. I have opposite and I have adjacent. Okay. So I want to find the angle and I have opposite over adjacent. Now I'm just I threw in a 0.5 there. You can put in a 1/2 if you want. I know that like violates a lot of laws of algebra to put a decimal in a fraction. I'm probably gonna get fired, but we'll just leave it down there, okay? Okay, because I just thought we're putting it in the calculator anyway. How am I gonna find that angle? Inverse, okay? So I'm gonna do second tan, 1 divided by 0.5. I just cheated and put that in there. If you want to put a 1/2 and make a complex fraction, knock yourself out. All right, that angle is 63.435, okay, or 63.43, sorry. Okay, 63.43. Okay, everybody all right with that? Okay, so this is 63.43. And now we just have to find our bearing. Okay, so again, this whole line, this whole angle here would be supplementary. This would be 180 degrees. So if I do 180 minus the 40 where it started, minus the 63.43 we just found, that's going to give me the bearing, whatever's left. And it turns out our bearing is 76.6 degrees. Okay, now that's not all that this wants in my math lab, okay? So that's definitely what's gonna go in this little middle box. But then it also wants the direction because a bearing is not just the degrees, it's the direction. So remember, we're down here, right here. This first box is either north or south. So where are we down here? We're south, okay? The second box wants either east or west, and we're definitely east. So that's what you're gonna put in each one. Okay. On Fortnite, look at me giving you Fortnite tips, okay? All right, sound good? Okay, 2 more. Maybe we can get through this today. We are going to get through it today, even if I have to sit here after you leave. Okay, here we go again. All right, my math lab 15, and then this is my math lab 16. Okay, let me get my camera to focus. Still not focusing. This computer's like, what in the heck did you do to me? Okay, so again, I think I forgot your little picture. But here's your little picture. Is this bringing back pre-calc memories? You had that one there too. All right, so you're supposed to pretend that it's turned like this, okay, like this. You're going up the coast of Florida, north-south. You're down there on the west coast, okay? And you know they're trying to build a little highway down there, but they've got this bay that shoots in there instead. And this little bay that shoots in there, okay, the engineers know they have to build a highway. So they did a cost analysis. They said, okay, how much does it cost to build a road around the bay? How much does it cost to build a bridge over the bay? Turns out the cost of the bridge is prohibitive. That means it's too much. It's too expensive to build a bridge over it. So they just decided to put a road around it. All right. So if they're going to go around the bay, they need this information. They want to know how much is this? What's the distance up, over, and down around the bay? That's what they're trying to find. Okay. Now, this looks like a beautiful little trapezoid, and if we were in geometry, I'm sure we'd have all kinds of trapezoid formulas, but we don't, and I don't know any. So we're going to turn it into some right triangles, because if we drop straight down from that point and that point, we're making two right triangles and a little rectangle, maybe a square, I don't know, okay? And we're going to find all of the links using that. All right, so let's see what we need. We got to draw this on here since you guys don't have it. So we're going to draw this way. We're going to go up. We're going to go over. We're going to come down. And there we go. There's our little bay. Okay. It tells us this particular angle is 140 degrees. It tells us this particular angle is 130 degrees. And then it tells us this whole horizontal mess of going around the bay is 3 miles. And then it tells us that the road is 1 mile deep. Okay, so if I'm going to come straight down with a right triangle and straight down with a right triangle, what I know is this side is 1 and this side is 1. Does that make sense? Because it's 1 deep. Okay, and then unfortunately this 3 is like the whole, this whole span here, which I don't really know. Okay, so we have a lot of things we have to deal with. All right, first of all, this side right here is a hypotenuse. Does everybody agree with that, since that's a right angle? So I'm going to call him C1, that distance, because you know we normally call a hypotenuse C. Okay, we don't know this flat part. We'll call him X. And then this other guy over here, he's another hypotenuse. So let's call him C2. Okay, does that sound all right? All right. So if I kind of, because you don't have to blow it up if you don't want to, but I didn't leave room. Here's C1, here's a right angle. My triangles are just too tiny. Here's C2, here's my right angle. All right. I need some more information. I mean, I don't really have any other information here, but I know this outside angle is 140. Could I find the inside angle? Sure, because this is flat. So what could I use if this is 140 to find the rest of it? Yeah, 180 minus. This is a supplementary angle situation. So to find this angle in here, I can do 180 minus 140. Okay, no. Good. Okay, so that would be 40 degrees. I can do the same thing for this one, 180 minus 130. This is a nice little 50 degrees in there. Okay, everybody good with that? All right, so now I need to find C1. Okay, well, let's see. I have 40 degrees and I have opposite and I want hypotenuse. So what function deals opposite and hypotenuse? Sine. Okay, so sine of 40 degrees equals opposite over C1. That's my hypotenuse. Now remember, this is that tricky situation where what we want is in the bottom. So what are we going to do to come up with this? We can just switch them, right? We can do the quick dirty thing where we switch it, where C1 is going to be 1 over the sine of 40 degrees. Okay, if you do that in your calculator, I'm going to take it out a few decimal places just because I'm going to what does it end up wanting it in? 2. So I'm just going to take it out 3. And then we'll add them all together later. My C1 is 1.558 miles. Okay. Now I'm going to do the same thing with C2. I have 50 degrees. I have opposite. I need hypotenuse. So I'm going to have sine of 50 degrees equals opposite over C2. Switch them. Okay. C2 is going to be 1 over sine of 50 degrees. Okay, C2 is 1.305 miles. Okay, everybody all right with that? Okay, so I now know this part, and I now know this part. All I have to find now is the part across there. Okay, so now's when you kind of can choose how you want to proceed with this. I've seen students do this a few different ways. What I was going to do is find this little portion and this little portion. I know the whole thing is 3. And then if I take 3 minus this and this, what do I come up with? My x. And then I can add this, this, and this together. And then I get everything I need. We only have 2 more examples on here. I'm going to go ahead and finish them on the recording. You guys go ahead and pack up and head back. And then I will send this to you. And then you can start it or stop it or just watch it without sound, whatever. Float your little boat. But that'll get us through section 8.1. Is that okay with everybody? If I do that, finish it and send it out? Okay, good. All right. Yes. I did, and the guy that I needed to talk to was at lunch. Thank you. So when I get done with your 2 problems, okay, so we'll just wait a second for the elephants to leave, and then we'll start again. Okay. Will you turn my lights on for me? Okay, I think that I can see, yeah, I can see better on the recording if I turn that off. All right, so here we go. I'm gonna put this down and scooch this over, and that is so much nicer for my recording situation. Okay, all right, so let's talk about what we have and what we don't have. So we now have this length. This length is 1.558. We have this length, which is 1.305. What we want is the length that connects them, okay? And what I know is that from here to here is 3 miles. So I'm going to find this little bottom portion of each triangle, and then I'm going to do 3 minus those 2 bottom portions to get this part that we want, which is x. Okay, so we already found C1, it was 1.558. We found C2, it was 1.305. Okay, so I'm going to put this here just so that I have a little more room. All right, so if I take this triangle and I'm trying to find this part down here, I'm going to call him A. Okay, I'm going to call him A1, and I'm going to call this little guy down here A2. Okay, so I have 40 degrees and I have every single side. So how about if we use, I have opposite, I want to find adjacent. Okay, so if I take the tan of 40 degrees, and that's the opposite over the adjacent, I can find A1. Okay, so I'm just going to switch these 2, and I'm going to do A1 is 1 over the tangent of 40 degrees. Okay, gosh, I wish I could make this a little bit there. It's a little bit bigger. Okay. All right, so that A1 is going to turn out to be 1.192 miles. Okay, now I'm going to do the same thing over here. I'm going to say, okay, the tan of 50 is opposite over adjacent. Okay, I'm going to switch these two. My A2 is going to be 1 over tan of 50 degrees. Okay. Then my A2 is going to equal 0.839 miles. All right. So this is what I'm trying to find. This is my X. This distance here is 1.192. This distance here is 0.839. And we know this whole part from here to here is 3. Then in order to find this X, it's going to be 3 minus 1.192 minus 0.839. That's going to give me an X of 0.969. Okay, so then this little connected part is 0.969 miles. That means all I have to do is add up all 3 of these, and then I have the total length of that highway. So my highway is going to be C1 plus X plus C2, okay, which is going to be 1.558 plus 0.969 plus 1.305. That gives me a total highway of 3.83 miles. And that's going to be my answer. Okay, so that was kind of a complicated one. It took a little bit longer to get there than we first anticipated, because you don't just need to find this side and this side. You also have to find this one. And in order to do that, you need to take the whole distance of 3 and do 3 minus this piece minus this piece. So that's kind of what took such a long time in finding everything. All right, last problem then for this section is example 14. This is a blimp. And again, I apologize for not having a picture on here for you. So I'm going to have to go back and add all my little pictures to things, but here we go. Okay, so here's what's going on. This is Soldier Field in Chicago, all right? This is the Adler Planetarium in Chicago, and they are 500 feet apart. Nope, they're not, I lied. We don't know how far apart they are. There's a blimp, like a Goodyear blimp. He's up in the air at a height of 500 feet above them. And this line that he's 500 feet above is from Soldier Field to the planetarium. If the angle of the depression of the blimp from the stadium is 32 degrees and the angle of the blimp to the planetarium is 23 degrees, it wants us to find this distance between here. So all we're doing is creating a giant triangle. We're cutting it in half since we know the height is 500, and then we have 2 right triangles. Okay, so let's do that. All right, here we go. I'm going to make a big triangle. Okay, probably should have made it bigger than that, but I didn't. And we know this height here is 500. So this creates 2 right triangles on each side there. Okay, now what else we know from this are these angles of depression. So we know that from the blimp down toward the stadium is 32 degrees. And from the blimp down toward the planetarium is 23 degrees. So what we're going to do then is take into account, if this is 32 degrees, if I can find this, because these two are complementary angles. So if I do 90 minus 32, this is 58 degrees. And if I do 90 minus 23, This is 67 degrees. And now we have two angles and one side of a triangle. What we want is this total distance. So if I find this distance, which would be A1, and this distance, which is A2, I can add them together to find the distance from the stadium to the planetarium. And there we go. Okay, so here we go. I have, let's see, 58 degrees, and I have the adjacent side. I want the opposite side. So opposite and adjacent, whenever they're involved, we're talking about tan theta. So tan of 58 degrees is going to be opposite over adjacent. And this is that kind of problem that we really like, because all we have to do is multiply these together. 500 times the tan of 58 degrees, and A1 is going to be 800.167 feet. There we go. Okay, over here, I'm going to do the same thing. I have 67 degrees. I want opposite. I have adjacent. So the tangent of 67 degrees is opposite over adjacent. That's easy, right in our calculator in degree mode. This is going to be 1177.926 feet. Then my total distance, okay, my total distance is going to be A1 plus A2. So on my calculator, I'm going to take 800.167 plus 1,177.9626, and I get 1978.09 feet. There's my total distance, and then I'm done. Okay, so this should help you get through section 8.1. All you have to do is change your numbers a little bit and draw your pictures. You're going to be given some nice pictures, so you don't have to totally imagine it. And then we'll start 8.2 on Monday.